All right, happy Friday, guys. Happy Friday. We only have 2 more Fridays left of school. 2 more Fridays, right? Next Friday and the Friday after that. And the Friday after that, 2 weeks from today, is the last day of school. Grades will already have been turned in. And summer break will start. All right, so what's a logarithm? As I told you before, logarithm is just another way of saying exponent. So when I ask you for the log of something, I'm asking you for the exponent of something. Okay? The exponent of a base. And you know how exponents work, right? Let's look back. Let's take us way back. Go way back. And we have an exponent, right? Like 7 to the 3rd power. Right? That just means 7 times 7 times 7. But let's look at the pieces of this. This big number here, that number that you're raising the exponent to, that's called your base. And that little number is called your exponent or your power, right? So a log also has a base. So when I ask you for the log of something, I'm asking you for the exponent of something. This is just a different way to write exponents because mathematicians they had unknown exponents. And so the variable was stuck in the exponent somehow. So they needed different ways to get into that exponent to solve equations. So they invented this way. And so the way you'll see it is it's called a logarithm. We call it log for short. Okay. And it's just another way of writing exponents, like it says right here. Another way of writing exponents. Okay. And you'll see it in this form. You'll see log, and then you'll see a little base, a little number on the bottom of the log. Okay. If you don't see a number, it's a 10. That's your basic one. If you don't see a number, it's a 10. So log, and then you see a base, and then you see a number. And then it equals an answer. The answer is the exponent. This is your exponent. So how does this translate? And the way you read that, sorry, before we do that, the way you read that is log base b of a equals x. That's the way you would read this log right here. Okay. And so since we're saying log base b, well, that means if we're going to write it in exponential, how does it look like regular exponential form? Well, we have a base of b, whatever that number here is, and it's raised to the x power because that's the exponent. Remember, I told you the log equals the exponent, and then that equals a. That's your result right here. So basically, if you want to look at it as an arrow, it's this base to this power equals that result. Okay? But again, log just says, hey, what's the exponent of this base? That gives me that answer, that a. And so we have some examples down here of what I'm talking about. So we're looking here. And so you see this is log base 3 of 9. So pretend you don't see this. Pretend you don't see this. So this is asking what exponent, what I can't write, hold on. What exponent of 3, right? That's the base of 3, is 9. So what exponent do I need to put on 3 to get 9? And the answer is 2. 2. So a log is just asking you what's the exponent. And so if I wanted to rewrite this as a log, as an exponential, it would be 3 to the 2nd power equals 9. Yes, it is that simple. It is that simple. So a couple of people in the chat said, Mister, is that it? Is that how simple it is? Yes. Now, does it get more complicated later, and can we use it for more complicated stuff? The answer is yes. But on the surface, at its basic core, a logarithm is nothing more than an exponent. It's a different way of writing exponents. Different way of writing something that looks like this. Okay. So let's try a few of these. So right here, we're converting. All we're going to do right now is converting. I'm going to give you a log, and you're going to convert it or translate it to an exponent. Okay? So let's look here. How would this translate into an exponent? Go ahead and try it. How would that translate? What is that saying in exponential form? The base is 6. That's right, 6. The exponent is 3. And that result is 216. That's what this is saying. this and this are saying the exact same thing. Yeah. Any questions? Is that confusing? Everyone getting it? Because that's pretty much it. Someone says, let's try another one. Okay, let's try another one. Let's look for a tough one. All right, what about this one? What about that one? There's a fraction, mister. I hate fractions. Okay, it's okay. It's okay. Fractions are fine. So what would this look like? Change that. I'll give you a second. I'll give you like 30 seconds. Change this to an exponential. What's the base? What's the exponent? What's the result? Okay, so yeah, 9 is the base. The exponent is 3 over 2, and that equals 27. Right? And if you wanted, this is your base, this is your exponent, this is your result. So it's that base to that power equals that result. Okay. Any questions? Do you understand this? Let me know. Let me see a thumbs up, a check mark, a yes, something. Oh, I didn't see a request. I'm sorry. Castaways by the Backyardigans. Sure. So once again, a logarithm, or log for short, is just another way to write exponents. And so when I'm asking you, or when anyone asks you what the log of something is, they're asking you, what's the exponent? So they're basically saying, okay, so this is the form that we write it in. And they're basically saying, okay, we have log, and we have a base of the log, base b of a equals x. So this is basically asking, what exponent of this base gives me this result? And the answer is that exponent. For instance, we looked at number 1. Log base 3 of 9 equals 2. So this is asking, what exponent of 3 gives me 9? So what exponent do I have to put on 3, on the base 3, to give me a 9? And the answer is 2. And the way we write that is 3 to the second power is 9. Right? So basically, when we're asking for a log, we're just saying, hey, what is that exponent with this base and that result? So it's basically written in a way so we can find the exponent. It helps us find exponents that are unknown. So that's what we're doing here. We did this one. We have log base 6 of 216 equals 3. That just means 6, that base, to the third power gives me that result. And then we did this fraction one. This is saying, what exponent of 9 will give me 27? And it can't be a whole number because 9 to the second power is 81, and that's already past 27. So we need to have a fraction. So that means, remember, the fractional exponent is radicals. And so that's how we get 27 if we actually worked it out. But we're not working things out right now. I'm just making you understand how to change from logs to exponentials. A log just means exponent. Is everyone clear on how to change a log to an exponent? And what a log is. Those are the two things you should know right now. What a log is just asking you for an exponent, and how to change from log to exponential. All right, I don't see any thumbs down. All right, so now that you can drive forward, going from logarithms to exponentials, let's see if you can go backwards. What if I give you an exponential? Can you write it as a log, like this one? So I'm going to give you a minute. Here's 14 squared equals 196. Write it as a log. Give you 30 seconds. All right, time's up. This is a little tougher. I had a couple of people in the chat saying, "Huh? Wait, how do I do this? Wait, I'm confused, mister." Okay, so let's just think about it. We have log. Oops, that's not a pen. We have log. Then we're going to have a little base right here, right? Then we're going to have a number right here, and then it's going to equal another number, right? So basically, we're going to say this is log. And what's the base of the log? Well, the base of the log is the base of the exponent, right? We're still using the same terminology. 14 is the base. So log base 14 of 196 equals 2. Remember, the log always equals the exponent because the log is asking for the exponent. The log's just saying, what's the exponent? That's what log means. Okay, you should put this down. Just logarithm means that's all it means. What is the exponent? So your log is always going to equal the exponent. So there you go. All right, you want to try one more? Let's see. Is there a tricky one? Try this one. Ooh, that's a tricky one. Try that one. Give you 30 seconds again. All right, time is up. So again, we have log. What's the base of the log? The base of the log is 8. And then the log always equals the exponent, which is 4/3. And then we always take the log of the result, right? The result, which is 16. Because we're asking, again, remember what we're asking. Log is what exponent with that base gives me that result. And the answer is 8 to the 4/3 power gives me that result. Yeah, we good? Are we good? And just one last thing. If you see this, log base 100, if you don't see a base, if there is no base, then the base is 10. That's your basic base. Okay? So if you don't see a base there, if you don't see a number right here, and for the base of the log, if you just see log, like if you look at your calculator, there's no base there, right? It's just log. It's base 10. Now, a log could have any base, but your calculator likes base 10 because our fingers and our whole number system is used in base 10. So that's our basic base that we use. And I'm going to show you a formula later that you can change any base into base 10, or you can change any base into any other base. Most people like to change it to base 10 or something called the natural log, base E. E is a number, yes. E is like pi, it's a number. But most times it's base 10. All right, everyone good on going from logarithm to exponent and then exponent to logarithm? Now's the time to ask if you are confused. All right, next page. Just what I was talking about, what's called a common logarithm. A logarithm with base 10 is also called a common logarithm and can be written without the base. So if you have this, log base 10 of x, you can just write log of x. It's the same thing. You don't need to put that 10 here. That it's kind of like that 1 in front of the variable. You can put it there, but you don't have to. You can, but you don't have to. Okay. So now that you know what a log is, I'm going to see if you can figure out the answers to some of these logs. And if you can't, how we use math and what we know about exponents to find it. Okay. Like for instance, this one, log base 7 of 49. What does that equal? Well, what is it asking? Again, like I always tell you, if you want to solve a math problem, understanding is the first thing you should do. So you need to understand what this is asking. This is asking what exponent, right? That's what log means, of 7 gives me 49, right? So that's what that's asking. When I say log base 7 of 49, I'm asking what exponent of 7 gives me 49, and the answer is 2. And you know how you can check that? You know how you can check that? You can change it to an exponential and see if it makes sense. Does this to this power give me that? Does 7 squared give me 49? And the answer is yes. Does that make sense? Mister, are they that easy? Are all of them that easy? I'm going to be honest with you. No, they're not. That's a basic one. That's an obvious one. And if it's not obvious, it's okay. I'm going to show you a way to solve it using a variable. Okay, so now let's go here. Excuse me. Give you 30 seconds. Solve that one. Tell me, evaluate that one. 30 seconds. All right, time is up. So this is asking what exponent of 3 gives me 27? And the answer is 3, because 3 to the third power gives me 37. 3 to the third power gives me 27. Okay, now let me show you. I'm going to show you the long way of doing this, because these are nice numbers. I don't know if you've noticed, but 13 and 14 right now, these examples have been really nice numbers with whole number answers. So the question should be coming to your brain, Mister, what if the numbers are not so nice? What do we do then? And so let me show you. So we're trying to find the log base 3 of 27, right? And we don't know what that is. So guess what we do? We say, okay, this is equal to something I don't know. X. We'll call it X. You can call it whatever letter you want. Doesn't matter. And then you change this to exponential. So what you do is you get this and then you change it to an exponential, which is 3 to the X equals 27. Okay. And so how do you solve that? How do you get that? Well, the way you would solve this is the reason why some mathematicians came up with logs, because there was equations that looked like this that they couldn't solve by hand. So they had to do something like this. But let's see if we can do something here. So the way I'm going to solve this is 3 to the X, and then I'm going to change 27 to 3 to the third. See that? I changed the 3 to the third. And once I have both bases the same, see how I have both bases the same on both sides? I can cancel them out, and I can say that exponent equals that exponent. So X equals 3. So that means this logarithm equals 3. Okay, so that's how we would solve it algebraically. Okay, if you didn't know the answer straight away, you would just change this log to an exponential and then solve. Okay. So let's see what I'm talking about. Like, because you know how sometimes we get a fraction? Like, yeah, actually, I'm going to go back. I'm going to go back to this one, like this one, right? Okay. So I'm going to go back to this one. Let's see how the answer is 16. You see how Well, we rewrote this, right? We rewrote this as log base 8 of 16 equals 4/3, right? We know it equals 4/3. But what if we didn't know that? What if we didn't know this equals 4/3? Let's pretend we don't know. We know it equals 4/3. We know 4/3 are our answer. But let's say we didn't. Let's say I told you to evaluate this. And then you'd say, 8 to what power gives me 16? 8 to the first power is 8. 8 to the second power is 64. Uh-oh. How do I get 16? So how do you solve this? So the way you would do that is you would say, okay, we know the answer is 4/3. But we would say, okay, this is equal to x because I don't know what it equals. And now I would change this to an exponential. Exponential is just this base to this power gives me that result, right? That's why we practice doing this up here, changing logs to exponentials so you can know how to do it. And you all told me you did. You all told me you knew how to change it from this to this. That base to that exponent equals that result, right? So now we're doing that. So let's change this to exponential. Ignore this. I know the answer is right here. I know the answer is right here. Just pretend you don't see that. And so this becomes 8 to the something power gives me 16 because that's what logarithm's asking. 8 to what power gives me 16, right? 8 to what power gives me 16. So now in order to solve this kind of problem, I need the bases to be the same. I need this base and this base to be the same, just like we did over here. Just like we did over here. You see that? You see how I changed 27 to 3 to the third? And the reason I did that is because those bases are the same. And once the bases are the same, I can drop them and just set the exponents equal to each other. And so if I do that, let's see, 8. Well, 8, isn't 8 2 to the third? Isn't 8 2 to the third? 2 times 2 times 2. So if 8 is 2 to the third, and then I just changed my 8 to the third, and then it's still to the x power, right? I just changed 8 to 2 to the third. And then 16, isn't 16 2 times 2 times 2 times 2? Isn't that 2 to the fourth? Right? And so now if I remember my properties, this is power to a power. So this is basically 2 to the 3x, which equals 2 to the fourth. Now that I have both bases the same, guess what I can do? I can drop that base, drop the base, and just set the exponents equal to each other. So this exponent should equal that exponent. So 3x should equal 4. And if I want to solve for x, I just divide both sides by 3, and I get x equals 4/3. So that's the exponent I need. And that's our answer, right? 4/3. So 8 to this power will give me 16. And that's how we evaluate logs. That's how we evaluate logs. Right? Some of them are obvious. Some of them are like, duh. What exponent of 7 gives me 49? 2. What exponent of 3 gives me 27? 3. But when I give you something like this, what exponent of 8 gives me 16? It's not obvious. So you just set it equal to x, change it to exponential, change it to an exponential. Now this looks very complicated, but all I have to do is change both sides so they have the same base. Okay, so I changed 8 to 2/3, and I changed 16 to 2/4. Right? So then once the bases are the same, I can drop the base because they're the same, and I can just say this exponent should equal that exponent. 3x should equal 4, divide by 3, x equals 4/3. Yes, I am recording this. Yes, I am recording this. Does that make sense? All right, let's look at another example. This one. How about this one? Try that one. I'm going to give you more than 30 seconds. I'll give you 2 minutes. To try that one. All right, time is up. Time is up. So let's see. So this is asking again. Make sure you understand what this is asking. What exponent of 64 gives me 4? That kind of sounds weird. Like, wait a second. It must be a fraction because 64 to the first power is 64, and that's already way bigger than 4. So how do we figure this out, mister? just like I told you. We don't know what this is, so we say this equals x, something we don't know. And then we change it to an exponential. This base to that exponent gives me that result. So 64 to an exponent we don't know, because that's what log is trying to find. We don't know the log, so we don't know the exponent. And that equals 4. So 64 to what, again, 64 to what power, to what exponent gives me 4. That's what this is asking. And so the only way to do this is to get this into the same base. So can you, this is 4. I can change that to 2 squared, but that's 4 to the first power. Is there any way to change 64 to 4 to some power? 4 to the, let's see, 4 to the first is 4. 4 to the second is 16. 4 to the third is 64. There you go. So 64 I'm going to change to 4 to the third, and it's still to the x. It's still to the x power, and that equals 4 to the first power. Mister, why are you putting the first power? Because we're going to drop the bases, and then we're just going to look at the exponent. So you need to remember that there still is a 1 right here. When you don't see an exponent, it's always 1. And so this 4 to the 3 to the x becomes 4 to the 3x equals 4 to the first. So we can drop the base. That's the same base, so we can drop the base and just say that exponent should equal that exponent. So 3x should equal 1 divided by 3, x equals 1/3. And that makes sense. If I put 1/3 right here, remember we talked about 64 to the 1/3? 64 to the 1/3, does that equal 4? Well, remember 64 to the 1/3 is just the cube root of 64, and that does equal 4. So yes, it does make sense. See how it's all connecting? Mister, this is connecting to the last thing we talked about with radicals and fractional exponents and stuff. Yeah, it is, because it's all connected. We good? You guys got that? All right. All right, guys, that's pretty much it for the lesson. We will do the change of base formula after. I just want you to work on the problems where you convert and evaluate. So on your homework, the change of base formulas, you can skip those problems. The change of base formula problems on your homework, you can skip those ones. I just want you to do the evaluate ones and the converting logs to exponents and exponents to log. Okay? All right, if you guys don't have any questions, that's pretty much it.